Good afternoon, learners. Today we'll be talking about analytical geometry. So, this lesson is just to do an introduction and clarify on some of the concepts that you have learned in grade 8, grade 9. Yeah. So, I know right now you're asking yourself, what are we expected to do in analytical geometry? What exactly is analytical geometry about? So, analytical geometry is simply about algebra. You must know your algebra. That's the first thing. You must know how to calculate your gradient, which is the most important thing. And you have learned how to calculate your gradient while you did linear graphs and stuff there in grade A. And the third thing is that you must know geometry. You did geometry, triangles, geometry of straight lines there in grade 9, grade 8. So those are the most important things that you must consider while doing analytical geometry. So let's start by talking about parallel lines. So they taught you about parallel lines. I will just touch on them because since this lesson is just an introduction to analytical geometry, it's not really analytical geometry. Okay. So in analytical geometry, we will be dealing with a Cartesian plane at some point, but we will come there. So parallel lines are lines that are equidistant from each other. So they are equidistant from each other. For example, if we have a line here, don't mind this line, just act as if it's straight. So if these two lines are straight and this is AB, this is CD, we are saying AB is parallel to CD. Remember, they've taught you that we show that lines are parallel using these arrows, right? So AB is parallel to CD because they are equidistant to each other. What does this mean? This means that if we take the distance between these lines from here, if it's 4, that means even here, if in here, the distance is 4, right? All the way going up to infinity. So that is what parallel lines mean. Parallel lines are this one. So from this thing, we can conclude that AB is parallel to CD. So this is the sign of showing that we have parallel lines, right? Okay, now let's talk about perpendicular lines. So don't mind my handwriting, just listen to what I say. If you can't see my handwriting, but as long as you hear what I say, it's fine. Because what I'm saying is what is important. So perpendicular lines, how do we see that lines are perpendicular, for example? That's the first question you're asking yourself. So perpendicular lines simply means that you have a 90 degrees where those lines intersect, or where the other line bisect the other line. So we can have an intersection and we can have lines bisecting each other. What I mean, intersection simply means that you intersect, it touches this line. Bisecting means that it cuts it into two equal lines, but we'll come there, it's fine. So perpendicular lines means where they meet, we have 90 degrees. For example, if you have AB and CD, if we say that AB is perpendicular to CD, we must have a 90 degrees here because they meet here, right? So that means that you see lines are perpendicular by what? By 90 degrees where they meet, right? So we can conclude that AB is perpendicular to CD. So in perpendicular lines, we are going to talk about a lot of things, even in parallel lines. I want to introduce this concept of a gradient, then I'll come back to parallel lines and perpendicular lines. So let's talk about gradient. So what I was specifically speaking about in terms of parallel and perpendicular lines is just a knowledge that you must know before you come to analytical geometry. Because now we are going to mix perpendicular lines and parallel lines with the concept of the gradient. So we know you have learned that gradient is small letter m, which is calculated by y2 minus y1 over x2 minus x1. So don't mind y2 and y1 if you don't know what are they yet. So those will find them in our coordinate. Remember, a coordinate consists of an x and a y value. That's where our y2 and y1 comes from. I will show you in the other video when we start calculating. Okay, so we are saying the gradient is y2 minus y1 over x2 minus x1. So the gradient is like a slope. You can just take it as a slope. Remember, even on the streets, there's no level. You'll find that at some point we have steep slopes, like the streets that are inclined, or the streets that are in level, like. So that's what the concept of gradient means. It talks about a slope. Right? So we are saying the gradient of parallel lines is equal. So the gradient of parallel lines is equal, meaning if we have two lines that are parallel to each other, AB and CD, meaning we can conclude that the gradient of AB is equal to what? The gradient of CD. So they like asking silly questions in maths. They can say that prove that AB is parallel to CD. So that means from your knowledge of gradient, you know that for me to prove that AB is parallel to CD, I can use what? The concept of gradient. I can calculate the gradient of AB. Then after, calculate the gradient of CD. Then if I find the same values, I can conclude that these two lines are equal. Why? Because the gradient of, these two lines are parallel. Why? Because of the gradient of parallel lines is equal. Ne? Okay? This means that even if when you are given, for example, they like testing. I will show you different types of questions. Let's say you have something like this. Here you have point A, which is 2 and 3, right? And here they say this line is parallel to this line. You have B. You have C, which is negative 3 and 1. You have D, which is 4 and 2, right? Let's say you have these two lines, né? And they are saying find the equation of AB. So while finding the equation of AB, remember this takes us to where AB is a straight line. So the equation of a straight line is either you find it using y minus y1 is equal to m into x minus x1, or y is equal to mx plus c. And we can see in both equations, for us to be able to calculate the equation of a straight line, we need what? We need to know the gradient. That's the first thing. So since we are required to find the equation of AB, how will we find the equation of AB while we don't have 2 points? And calculating the gradient needs 2 points. And one other thing, you can just write this thing. Gradient of a straight line is constant. Before we go far, gradient of a straight line is constant. That means even if we had E here, that means gradient of AB, if we use AB, is going to be the same even if we say gradient of AE or BE. It's the same because it's the same straight line. So the gradient of a straight line is constant. That's what it means. Okay? So now, how will you find the equation of a straight line AB while you don't have 2 points to calculate the gradient? That's where the parallel lines come in. So we said the gradient of parallel lines is equal. That means we can just calculate the gradient of what? Let's say here we have D, right? We can calculate the gradient of CD, right? Then after calculating the gradient of CD, we know that the gradient of CD will be equal to the gradient of AB. Why? Because of they are parallel lines. They are parallel to each other. So now we have what? Let's say when calculating the gradient of CD, we are going to find that the gradient of CD is, for example, let's say it's 1/7, for example. Ne? So if we find that the gradient of CD is 1 over 7, that means even the gradient of AB is 1 over 7. Then now we can find the equation of a straight line since we have one other point. We will come on that one. So now I'm just showing you how important is this concept of gradient of parallel lines. So now let's talk about the gradient of perpendicular lines. Okay, so you've been speaking about the gradient of parallel lines. What about the gradient of perpendicular lines? Okay, we are saying the product of the gradient is equal to -1. So we are saying the product of the gradients is equal to what? -1. When we are talking about the perpendicular lines. Okay, what does that mean? Okay, you can hear what I'm saying, but you don't understand. You can't visualize it. Okay, let's check. Perpendicular lines, we have 90. A, B, C, D. We know that AB is perpendicular to CD. So the concept of perpendicular lines, this simply means that the gradient of AB multiply, product means multiply by the gradient of CD must give you -1. Right? So this is what it means. So this simply means that if you are given that AB is perpendicular to CD and they give you the gradient of, let's say you are given that the gradient of AB is 1 over 2 and they say calculate the gradient of CD, you are going to go where? You are going to come here. And from here, you know the gradient of AB is 1 over 2. The gradient of CD, you don't know it, it's -1. Right? Then the gradient of CD, you divide both sides by 1 over 2, which is the same as multiplying by 2 both sides. Then you're going to have that your gradient of CD is -2. That's how the perpendicular line thing works. So if you have perpendicular lines, that means that the product of their gradient is equal to -1. If you have the gradient of one line, you can calculate the gradient of the other. Using that, the gradient of the product of the gradient of those two lines is equal to -1. Okay, then one more thing about the gradient. So we have learned about that the gradient of parallel lines is equal, the gradient of a straight line is constant, and the product of the gradient of perpendicular lines is equal to -1. Okay, so that was an introduction to analytical geometry. So you have only learned one new concept: linking gradient with parallel lines and perpendicular lines. So in the next lesson, we'll be looking at calculating the area of a square, a palm, a parallelogram, a triangle, and those things and their properties, right? So, which is also important in analytical geometry. Okay, thank you. This is the end of this lesson. If you want your lessons, you can come and join Tutor King. If you want info about Tutor King, you can just leave a comment. Thank you. Don't forget to like the video.